Welcome to another coding tutorial, and in today's video I'm going to show you how to make these exploding hearts. Let's start by looking at some heart equations. I actually had done a different tutorial where I'm using the specific equations here that provide us with this heart shape, but why don't we try a different one today? And the one that I want to try is this one. And we have parametric equations here, which are equations of x and y as a function of a different variable. And as you can see here, the variable is t. And how we're going to do this is that we're going to provide a variable t that goes from 0 to 360 to get a return value of x and y that provide us with a curve of this heart shape. All right, so we're going to use a for loop that goes from I equals to 0 to I less than 360, I plus plus, and in this case, I is the variable t that you saw in the equations. And how about we set x to be equals to the square root of 2, and we can use the built-in function sqrt for square root, and then multiply it by sine of t or sine of I to the power of 3, right? And we can use a function pow where the first argument is the base, which is sine of I, and then the second argument is the power that we want to raise it to, which is 3. All right, and then for the y side, we need power of negative cosine of I to the power of 3 minus power of negative cosine of I to the power of 2, and then plus 2 times cosine of I. Actually, this has to be positive. All right, and then let's draw it out in a shape of a circle. So the ellipse function takes in a total of 4 arguments. The first 2 are the x and y coordinate of the center of the circles and then the diameter. All right, we got something here. So why don't we move this whole thing to the middle of the canvas, and by this whole thing I mean the origin. So we can use the translate function, and then we're going to translate it to width divided by 2 and then height divided by 2. All right, and we cannot really see it as the shape of a heart, and that is because the radius is too small, and the radius is right now equals to 1. So what we want to do is that we want to multiply our equations by r, both x and y. And then how about we set r to be equals to, let's do 30. One more thing that we need to do is that we need to change the angle mode from radians to degrees, and we're going to do that by putting in angle mode and then giving in the argument as degrees. So the shape of the heart is upside down, and that is because our y-axis goes from negative to positive from top to bottom. So what we need to do to this r here, we need to actually put it as negative r. So this heart shape has a total of 360 circles. What if we want a smaller number but still in a shape of a heart? What we can do is that instead of providing 360 here, how about we set num to be equals to, let's do 50. And then what we need to do is that we just need to loop it from I equals to 0 to I less than num. But then we need to be able to provide a different variable for this I here. Let's call it angle. And this angle here needs to be spaced out evenly between 0 and 360. And what we can do is that we can divide 360 by the number. And this will get us the evenly spaced amount. And then we just multiply it by I. And then we need to not forget to replace all of these I with the new variable angle. And ta-da! Now we have 50 circles in the shape of a heart. How about we make it a little bit bigger? Let's do 100. All right. Now I actually want to put this set of equations in a different function, and I'm going to call it heart equation. And the parameters that I want to put in here are angle and r. And this way we can just put these x and y equations in here, and then we're going to return a vector, and a vector can hold 2 to 3 values, and I'm going to use it to return 2 values, the x and y coordinates, and it's going to return a new vector. And I can use a method called createVector, which is a method within a vector class, and then we can provide the x and y coordinates. So now inside here, I can just set, how about we set a variable called position, POS, to be equals to this function here, heart equation. And then we're going to provide angle and r, right? And angle we already have calculated here. So angle, and then r, which is a global variable. And then this should work the same way. Oh, and then we need to provide the new variable here, which is going to be pos.x and pos.y. We want the x value of this position vector and the y value of the position vector. All right. And this way you can change the equations to whatever you want, right? It can be a shape of a heart, or if, let's say that I set an equation to be just a circle, right? R times cosine of angle and y equals to r times sine of angle. And now we just get a circle. Next, I'm going to put this set of code in a class called heart. And so I'm going to come to this arrow here, click the plus sign, click create file, and then I'm going to call this file heart.js. And before we do anything, let's go to index.html file. And then here we're going to copy and paste this line of code, change the name to the name of our new file, heart.js. And this is how you integrate a new JavaScript file into the program, right? So now we're ready. So let's start with the word class. And I'm going to call this class heart. Then inside the constructor function. First, let's provide the x and y coordinate for where we want to translate the origin to be. So x and y. All right, and then how about we do another method called display heart. And then for this one, what we need is that first we just need to move this whole thing in here. All right, and then in translate, we want to translate it to this .x and this .y, right? And then we also want to put this heart equation inside our heart class. All right, and as a method within a class, we don't need the word function. And now all we need to do is that to call a method within a class, we need the word this dot. All right, let's go back to sketch.js. How about we create one heart object? Let's call it h, and h is going to be a new heart object. And I'm going to actually just create the same exact thing as this. So I'm going to provide the x and y arguments as width divided by 2 and then height divided by 2. And then let's just call the method display heart. All right, we get the same thing. Next, how about we create a function called mouse pressed. And what I want to do is that instead of creating a heart object in the middle of the canvas, I want to create a new object every time I click the mouse. And I want it to be at the location of my mouse. So what we need to do is that first I want to change from a variable h to an array called hearts. And we're not going to create any new objects inside setup. What we're going to do is that we're going to actually create a new object every time we click a mouse. So I'm going to push a new hearts object. And we can just do this by providing the name of the array and then calling the function push. And this is going to add a new object inside our hearts array. And to do that, we need to call new heart, right? So the same thing as how we called the object previously. So where do we want to create it? We want to create it at mouse x and mouse y, right? Which is the x and y location of my mouse. All right, and then instead of just calling display heart on just one object h here, we're going to use a for loop that goes from I equals to 0 to I less than hearts.length, right? And this length is going to change every time we click. All right, and then now we just call this on all of the objects inside the hearts array. Let's try that. oh, it's not making a heart object on where I put my mouse. And that is because, why? It is because of this translate function, right? Because whenever we call transformation functions, we need to think about whether we want to put in two important functions, push or pop, or not. And what push does is that it saves the transformation functions, specifically in this case, translate the origin to this.x and this.y, right? And the pop function returns it back to the default setting, which is when the origin is at the top left corner of the canvas before it's called this translate function again. All right, and if we do this, now it works as intended. So two things I want to do before we move forward is that I want to, instead of putting in num and radius here as global variables, I'm going to actually randomize that inside our heart class. So let's do this.r to be a random value between, how about 10 and 30. And let's do num to be between 30 and 50. And I want this to be an integer. So I'm going to use the function called floor. So if we do that, we need to also make sure that we put this.num here. And for r, it will be this.r. I think that's it. Let's try it. All right. Maybe we can make the radius to be bigger. How about 30 to 100? Okay. Now, how we're doing this is that we're calling the ellipse function here based on the position that we get from this.heart equation here. But what I want to do is I want to create another class called particle because I want to be able to manipulate the position of each of the circles that makes up a heart shape. So let's just do the same thing where we create a new file by clicking the plus sign here, create file, and I'm going to call this class, this file, particle.js. And then we need to go to index.html file again and then add this file into our program. Now inside the particle class, we're going to create a constructor function and we're going to provide x and y coordinates. And I'm going to set it as a vector. And this vector I'm going to call position and set it to a new vector at position x and y, and then we're just going to display particle as an ellipse at position x and position y, and let's do the size of 10 to be the same. Now if we go back to heart.js, what I'm going to do is that first I'm going to create a new array. Let's call it shape. Then we're going to use a for loop that goes from I equals to 0 to I less than. Basically, we're doing this same thing here. So this dot num I plus plus. So basically what we're doing is that I want to create a bunch of particle objects first, and then we're going to call the display particle method here. And then in our sketch, we're calling the display heart. So now let's create the new particle objects. So we want to create it at same. So first we need to calculate angle again. And then we're going to put in new particle objects inside the shape array. So new particle, and it is going to be at this position, right? So we just need this pose.x and then pose.y. And all we have to do inside the display heart function now is calling the display particle method. Okay, should work. Nope. Oh, and this has to be this dot shape. Yay. Okay. So why am I making it more complicated? It is because now what we want to do is that we want to be able to control each of the points here. So let's go back to particle.js. How about we create 2 more variables here? I'm going to call it velocity, and let's set it equals to, how about 1. So velocity is the rate of change of the position. And so what we want to do is, let's do update particle, and we're going to add one vector with another. So we want to add the position vector with the velocity vector. So this dot velocity. So what this does is that whatever the position is, we're moving it at 1 to the right and then 1 down in the x and y direction, right? So let's try that. So if we go back to heart.js here, to not be confused with display heart, I'm going to actually call another function called update heart, and we're basically going to call all of the points inside the heart shape, the heart array, the shape array, and we're going to call update particle. And then inside sketch.js, we need to make sure that we call that method also. So update heart. All right, did I put in update heart here? Right, okay, let's run. All right, so now the heart is what? It's moving 1 to the right and then 1 down every time the draw loop is called. So now we're basically controlling each of the points inside the heart. So let's go back to particle.js again. One more thing that we can add is acceleration, right? And acceleration is the rate of change of velocity. So let's say that we put it at 0, 1. And we're going to put in 0, 0 here. So I want the velocity to be at 0 first, but then I'm going to add the acceleration vector onto the velocity vector. Let's see what happens. And this is how you simulate gravity, right? So basically, the rate of change of the velocity, which is acceleration, is at 1 in the y direction every time the draw loop is called. If we do 0.1. Meaning that this heart is falling at a faster and faster rate every time. And it looks like gravity. But you might wonder, why can't we do this in the heart class, right? Because it seems like all the particles are changing at the same rate. So we can actually also vary let's say we vary the velocity of each of the points inside the heart. So instead of putting it at 0, 0, what if we set it randomly, and we can actually use a p5 vector function called p5.vector.random2d. And this method returns a random vector with a size of 1, but in different directions. So let's say that I put in the acceleration at 0, and then now, you see that? Each of the points are moving in different directions. And now if we add gravity onto that, by creating a particle class that allows us to control the motion of each of the points, you can simulate something like this. And Daniel Schiffman from the Coding Train has a whole lot of videos on particles and particle systems, so I recommend you watching his tutorials on those as well. And actually this tutorial is inspired by his tutorial on fireworks, so I will link that one down below. We can actually stop here, but what I actually want the heart to look like is that I want the heart to expand to a certain size before it falls. So I'm going to go back to my heart.js file, and I'm going to set 2 more variables. The first one is dr, which is going to be the rate at which the radius changes. How about I set it to 0.1, and then I'm going to set a Boolean variable and I'm going to call it fall, and then I'm going to set it as false, meaning that when the heart object is created, it doesn't fall. It expands first and then it falls at a certain point. But when is that? So let's come to update heart here. So what I want to do first is that I want to comment out this update particle method, and I want to update the x and y coordinates of my heart shape. So what I need to do is I need to set angle to be the same as this again, and then I'm going to call the method heart equation again. So this dot heart equation of what? Of angle and r, right? Angle and r, which is this dot r, and I'm going to set it to actually this dot shape of I dot position vector, right? So it's going to give me new x and y coordinates. But if this dot r stays the same, it will be the same. So what we want to do is that we want to actually increment this dot r by this rate. All right, so now my heart is expanding. Let's move it faster. All right. Now let's give it a limit at which it stops expanding. So how about we set a limit to, let's do 100. Then here we're going to say if this dot r is less than this dot limit, then we're going to expand it at this rate. Else we're going to set this dot fall to true. All right, and then inside this for loop here, we're going to say if this dot fall is equals to false, right? If it's false, then we're going to change the x and y position based on the new radius. But else, we're going to call this update particle method, which is when it falls, each of the points fall. Expand, 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 fall. All right. And you can play around with the variables here, right? So this .dr here can also be randomized if you want it faster, 1 to 3. How about we set this .r to be smaller so there's some room for it to expand. All right. A couple of more things before we end here. The first one is that, as you can see, now all the hearts are off the screen. And because we will be clicking a bunch more hearts, we want to be able to remove these hearts from our array. So what we're going to do is we're going to go back to particle.js and we're going to create a new method, and I'm going to call it offscreen. And it is going to check if this .position.y is greater than height or not. So it's off the screen, right? Then if it is, then please return true, else please return false. Okay, now let's go back to heart.js. Inside this update heart function here, no, actually display heart, I want to check how many of the points inside my shape array is actually off the screen. And so what I'm going to do is that I'm going to create a variable called sum, started at 0. And then in here, we're going to say if this dot shape of I dot, that function was off screen, right, is equals to true. When it's true, then I want to add 1 to the sum. And once if sum is actually equals to this dot num, right, which is the total number of circles inside my shape array, then return true. So how about we print sum here. And then we need to, actually we already called this display heart. Okay, let's click run. All right, so did you see that? When it's off the screen, then it prints the sum here. Okay, so now actually what we can do, just to make sure that we delete all of the hearts that are off the screen, we need to go back to sketch.js. Then we're going to actually remove the hearts object, right? So we can do that by actually just use a function called splice, and we are going to provide the index of where that object is inside our hearts array, and the other argument is how many number of objects do we want to delete from this index. We only want to delete just one, right, which is this one at index I. And also to make sure that the hearts objects are being deleted, I'm going to also print the length of my hearts array. So actually I'm going to also set the size of my canvas to be smaller so that we can see when the hearts are off the screen. So, oh, something's wrong. Okay, let's go back to here. So if I print done here, let's go back to sketch.js, hearts.splice. Silly me, what I was doing is that I'm basically splicing or removing the hearts object just on all of the heart objects because I don't have any conditions at all. So what I want to do is that I want to say if what? If hearts of I dot, what was the name of, actually we want to not just return true here, we want to set this dot, how about done, to be true, and then it will initially be false. So if hearts of I dot done is equals to, if this boolean variable is equals to true, then we want to delete it. Okay, so I'm going to click a bunch of them. So let's look at this. You see, my length of this hearts array goes up as I click, but then as it moved off the screen, now the length equals to 0. All right. So I want to show you something. It's okay right now visually, but actually doing the splice function this way is not ideal. And the reason that it is an issue is because, let's look at this example. Let's say that we have an array of size 5, and we want to splice, or we want to remove an object at I equals to 2. When that object is removed, all the objects to the right of it actually gets moved to the left. So now the object that was I equals to 3 previously now is occupying the position where I equals to 2. And now in our for loop, we already went through I equals to 2, so now it goes to I equals to 3. So the object that is now replacing the one that got spliced is never get checked. And that is an issue. And how we can fix this is that instead of going through the for loop from I equals to 0 to I less than hearts.length, we can do it in reverse. So we can go from the back, which is when I equals to hearts.length minus 1, and then increment down to where I is more than or equals to 0. And this way, when we removed an object and everything gets moved down, all the objects inside the array will still be checked. So what we have to do is that we need to change from I equals to 0 here to I equals to hearts.length minus 1. And then when I is more than or equals to 0, and then we want to increment down by 1. And we should still see the exact same thing. And this already fixed the issues that I mentioned. All right, so now it's time to make it pretty. And how about we go back to particle.js, and then we're going to put in fill. Let's create a variable called this.c, which is going to be our third parameter here. So this.c will be equals to c. And then inside our hearts.js, I want to create a new color array. Let's call it colors, and it's going to be this color here, this color array. And then we're going to, inside where we create the particle object here, actually this has to be before, and then we're going to say this.c is going to be random colors from this array here. Then we're going to provide a third argument inside here to be this.c, right? Let's try. Okay, then I want to also give it no stroke. And then how about we give a random radius diameter between a value of, how about 1 and 10, and we'll just put it here. This will be our random diameter. And then how about we change the background to this color here. All right. That's nice. As you can see here, all the points have different diameters, right? For each of the hearts here. And you can actually also keep all the size to be the same per each heart shape, and you can change the diameter inside the hearts class instead. I hope that you enjoyed this tutorial, as it introduces you to the new concept of particles and particle systems that allow you to control each of the motions of each of the points within the system. And why don't you give it a try, changing some equations from a heart to maybe a star, a circle, whatever you like. Give this one a try.